This video is going to be about the binomial distribution. First, let's talk about the conditions of the binomial setting. We have 4 conditions abbreviated as BINs. First, binomial distributions must be binary, which means there are only 2 possible outcomes, which we call a success or a failure. Next, it must be independent, and that means knowing the result of one trial does not impact the outcome of another trial. Next, the number of trials n is supposed to be fixed for a binomial setting, and this is very important. Next, the probability of success, p, must be the same for each trial. Let's look at an example of verifying a binomial setting. Let's say that we are rolling a fair die 3 times. What is the probability of rolling a 6? Let's check if this is binary. Our success would be rolling a 6. Our failure would be not rolling a 6. These outcomes are independent because the number rolled is not affected by the previous number rolled. And then our n value, which is our number of trials, is 3. It is fixed ahead of time. And then our success probability is p, and that's going to be equal to 1/6 for every trial because it's just equally likely to roll any number on the die each time. Here, let's look at the binomial mean and standard deviation, which are these 2 formulas over here. And whenever a question asks for the expected value, that's when you're going to use this mean formula over here. This is definitely something important to know. Now, let's look at the binomial formula. And this here, we don't need to know the exact details of this for the AP Stats exam because we will use our calculator to do this for us. But something that I did want to highlight here is that this is called the binomial coefficient and is the number of ways of arranging k success among n observations. So n is your number of trials, k is going to be your specific instance, which we will look at in further examples. This notation here is n choose k, which means to choose k out of all n available. Now let's look at binomial probability. This is also a formula that you do not need to memorize for the AP Statistics exam because we will be using our calculator to help us with these kind of problems. But anyway, here, if x has a binomial distribution with n observations and a probability of p success on each observation, the possible values of x are 0, 1, 2, 3, n. And this is probably important to just know conceptually. It might come up on the exam, like what are the possible values of a binomial variable? It's from 0 to n, when n is going to be your number of observations, your number of trials. And if k, which is going to be our specific instance, if k is any one of these values, then now we have this formula. I want to just reiterate that k basically means our specific instance, which in the rolling a die example would be rolling a 6. So rolling a 6 would be k. That is what we are checking the probability of. And over here, I just want to highlight something important, that 1 minus p is equal to q, which q in statistics is denoted as the probability of failure. Let's look at how we can use the calculator to solve these binomial distribution problems for us. So these functions will do what these formulas we talked about are capable of doing. So we have 2 functions that are important to us here, the probability distribution function, abbreviated as PDF in the calculator, and the cumulative density function, abbreviated as CDF in the calculator. Both of these can be accessed on the calculator by clicking on the second button and then clicking on the vars button, right? And this one is going to be seen as binom PDF, and then this one over here is going to be seen as binom CDF. P standing for probability, C standing for cumulative, and the parameters of these are going to be n, which is going to be our number of trials fixed ahead of time, p, our probability of success, and x. So lowercase x is the same as k, like what we were seeing over here. It's the same, it's just how the calculator formats it. TI-84 just doesn't use k and uses lowercase x instead. But that's going to be that specific instance that we're looking for. So PDF assigns a probability to an exact instance x. So that's like the probability of rolling a 6 on a die. And here, the cumulative density function, the CDF, calculates the sum of probabilities up to and including x. And we're going to look at some examples of this so we can understand it some more. So let's go back to that same example of rolling a dice 3 times. And something that I want to note is that whenever you see a probability, distribution problem, the first thing you should do is, check the conditions. So is that 4 conditions, bins, is it binomial or not? So here, 3 times we got our trials fixed. Binary, independent, probability of success is also fixed. That's just something you need to go over in your head. Sometimes in the exam, they might even ask you to write it out, verify that this is a binomial distribution, and you'll just write out those 4 steps. We know this is binomial, so now we can proceed. So we were just talking about this, the probability of rolling a 6. Always include your P statement, your probability statement, x is equal to 6. That's the specific value we are looking for. Binomial PDF, n is equal to 3. That's 3 trials. P is equal to 1/6, our probability of success. And x is going to be equal to 6. So this, when we type it in the calculator, we'll find the probability of rolling a 6, rolling that specific number in that specific instance. So whenever your probability statement is going to have an equal sign, you're looking at the probability of one instance, that is when you use PDF. All right. Next, let's look at the probability of rolling a number that is at most 3. So your first step should be process this into a P statement. So this would be x is less than or equal to 3 because it's at most. Now that we have a less than or equal to and not an equal sign, we're going to be using CDF because this is cumulative probability that we need. We need the sum of probabilities. This is the probability of rolling a 1 plus the probability of rolling a 2 plus the probability of rolling a 3. We need a sum, so we're going to use CDF. Our n and p values will stay the same. X is equal to 3 because remember CDF calculates sum of probabilities up to and including. So that's 1, 2, and including 3, which is exactly what we need. So when we type this in the calculator, we're going to get an answer. It'll be a decimal value. That's what we write down. Now let's look at the probability of rolling a number less than 3. Okay, so here 3 is not included. And binomial CDF calculates up to and including x. So now we have our initial P statement, which is x less than 3, probability of rolling something less than 3. Now we need to rewrite it and say, well, that's the same thing as x is less than or equal to 2. And if we look over here, we can realize that, 1 and 2 is less than 3. And I would definitely say that writing this out here, just really quickly figuring it out, is really helpful. And then now, when we do our CDF, n and p stay the same, and x is now equal to 2 because we need up to and including 2, because that is less than 3. Now let's look at what is the probability of rolling a number that is at least 3. So that is 3 or more. And now we have our P statement over here, and binomial CDF only sums up probabilities from the left. But we are looking at probabilities of values to the right of 3, 4, 5, 6. Binomial CDF cannot do that. It can only sum up probabilities from the left. So on its own, really only works for our less than or equal to scenarios. So now we got to do something. We must rewrite this probability statement in terms of less than. So how do we do that? Well, it makes sense if you list out 1, 2, 3, 4, 5, 6, if you list out your outcomes. So here we're rewriting x is greater than or equal to 3 as 1 minus p of x is less than or equal to 2. So we have 1. So the probability of all of these outcomes is 1. And from that, we are getting rid of what we don't want, because 3 or more is what we do want. But we don't want 2 and 1. We don't want anything that's to the left of 3, so that's what we're getting rid of. We're subtracting that from 1, and then now we're going to do 1 minus, and then we're going to do the binomial CDF for this part, the part that we're getting rid of. We're getting rid of the probability of x is less than or equal to 2, so that's why we say x is equal to 2. But do not forget in your calculator to write 1 minus and then binomial CDF. That's all for this video. Thank you for watching and good luck studying.